Hello, we're going to pick up in 7.5 in calculus. I skipped the third example. It's a fun problem. If you want to ask about it, you can, but it's more for you to try. To get some more realistic problems. A 20-foot chain weighing 5 pounds per foot is lying coiled on the ground. How much work is required to raise one end of the chain to a height of 20 feet so that the whole chain is fully extended? Now, when we pick up a chain, if we lift it, say, 1 foot off the ground, the other 19 feet will be supported by the ground because they're sitting on the ground. So the idea here is the general weight of this thing is changing, but we know that the weight is 5 pounds per foot, so depending on how high we've raised it, it's 5 times y, where y is the height we've raised it to. Now we're starting fully on the ground, and we're raising it 20 feet in the air. Of 5y dy will give us the variable amount of work that we're doing to lift this up, or the force, the work that's expended to raise this. And again, it's a very easy setup. The integral of 5y is 5 halves y squared, evaluated from 0 to 20. When we plug in 0, it's 0. So 20 squared is 400. So this is 5 halves times 400, which is 5 times 200, which is 1,000. And we were raising it in feet, and its weight is in pounds. So this is foot-pounds. So it's not so bad once the problem is set up. Now, we can also do this with gases, the work done by gases when they expand. A quantity of gas with an initial volume of 1 cubic foot and a pressure of 500 pounds per square foot expands to a volume of 2 feet. Find the work done by the gas. And it says assume pressure is inversely proportional to volume, that is P equals a K, a constant for that gas in particular, divided by V, a volume. So we can use what we know about the gas at 1 cubic foot, that is the pressure of 500 is equal to our constant divided by our volume of 1. Well, K divided by 1 is just K, so we know the constant here is 500 for this gas. What are we doing? We are expanding the gas from 1 to 2 feet, cubic feet, and we know that what's changing? The volume, that means our denominator is going to have our x in this case, and our constant is 500 dx. When we integrate this, the integral of 1 over x is the ln of the absolute value of x. This is evaluated from 1 to 2. Since we are plugging in only positive numbers, we don't really need the absolute value here, but this is 500 times the ln of the absolute value of 2, minus 500 times the ln of the absolute value of 1. Any logarithm evaluated at 1 is 0, so this becomes 0, and we don't need the absolute value here, so this is just 500 times the ln of 2. And these two applications in the spring applications are the most likely ones you will see on the test, and so this is really all for 7.5.